Hi everyone, welcome to the Dynamic Maths channel. Today we will be learning about indices. Indices are common in algebraic problems and can be confusing if one does not know the properties of indices. Grab a pen and paper and let's get started. What is an index? An index is a singular noun for indices. The index, also known as the power, tells you how many times you have to multiply the number by itself. For example, this number is pronounced as 2 to the power of 4. It means that you multiply 2 by itself 4 times. Multiplying 2 4 times gives us 16. See, it is that simple. However, it will get complicated when there are several rules to follow. As long as you nail down the concepts for each rule, you'll find solving index questions easy. There are about 6 rules, and let's go through them one by one. The first rule is the power of 0 rule. Here, any base, whether it is a number, a noun, or a function, with the power of 0 will always equal to 1. This rule is simple to follow. The only tip here is, when you notice a base has a power of 0, you can simplify it to 1. Here are 3 examples. In the first example, we have 10 to the power of 0. By following the rule, we can equate it to 1. Then we add both numbers to get 6. In the next example, p has a power of 0. We equate this to 1 and solve for 2 to the power of 3. We get 9. In the last example, we notice that x plus 3 has a power of 0. Again, we simplify this term to 1. Then we expand the x plus 2 squared term to finish the computation. We get x squared plus 4x plus 5. This rule states that whenever a base has a power of 0, you just equate it to 1. The second rule is the negative power rule. The value of the power is negative. It means that the base is on the wrong side of the fraction line. We can flip the base to the other side. For example, from the numerator to the denominator. Let's look at examples to demonstrate. In the first example, we have 10, which has a power of negative 2. Based on the rule, we flip the number to the denominator and solve. We get 3 over 100. In the next example, p has a power of negative 5. We flip this number to the numerator and solve. We get 10 times p to the power of 5. In the last example, we notice that x plus 3 has a power of negative 1. Again, we repeat the same procedure by flipping the term. Then we expand this term to solve the question. This rule states that whenever you see a power with a negative value, you have to flip it from the numerator to the denominator or from the denominator to the numerator. The third rule is the fractional exponents. The fractional exponents expresses power and roots together. The numerator is the power of the base and the denominator is the root of the base. Here are some examples to demonstrate. In the first example, 9 has the power of 1 over 2. Therefore, we need to convert it into a root form and solve. We get 3. In the second example, we have 2 over 3 as the exponent for 64. We can solve the root index first, then we solve for the power. By solving the root first, we get 4 to the power of 2. After solving this, we get 16. The next example is quite tricky because it has unknowns, but it can be done. We can simplify the equation by factoring in. First, we create the root. Or it can just be a square root. We can factorize this term into we have a square term here and a square root term, so they cancel off each other. We get x plus 2. Just remember, when you deal with fractional exponents, the numerator is the power of the base and the denominator is the root of the base. The fourth rule is the addition rule. When you multiply numbers with the same base, you can add the exponents together. A common error here is that the addition rule does not apply to the addition of the same base. Here are some examples. In the first example, we can combine 2 to the power 3 times 2 to the power 2 times 2 to the power 3, but we cannot combine 2 to the power 3 plus 2 to the power 2. Let us do that first. After combining, we solve the power and add them normally. In the second example, we can multiply the p terms to get p to the power of 2x plus 3. We cannot use the addition rule on the minus p term, so we leave it at that. You will get p to the power of 2x plus 3 minus p. In the third example, we can add fractional exponents together as the base is the same. This will result in x plus 2 squared. First we write the terms, add the exponents. We can simplify this term as 2 and we get x plus 2 squared. We expand this term to get x squared plus 4x plus 4. Just remember, when using the addition rule, make sure the two same bases multiply each other, not add each other. The fifth rule is the subtraction rule. It is the opposite of the addition rule. When you divide numbers with the same base, you can subtract the exponents. Take note of the order as well. The first term always gets subtracted by the second term. Let's look at some examples. In the first example, we can simplify these two terms by using the subtraction rule. Then we solve the power and add them normally. We get 8.5. In the second example, we have p to the power of 2x over p to the power of 3. We can convert this fraction into a linear function, where p to the power of 2x divided by p to the power of 3 minus p. Now by using the subtraction rule, we can simplify this equation. We get p to the power of 2x minus 3 minus p. In the third example, we can combine the fractional exponents as the base are the same. We get 2 over 2, we can simplify it to 1. This gives us x plus 2. Just remember, when you have two bases dividing each other, we can subtract the exponents together. Next is this rule number 6, which is the multiplication rule. Here we have x to the power of m in brackets to the power of n. We can safely remove the brackets to give m times n. Here are a few examples to demonstrate this. In the first example, we have 2 to the power of 3 in brackets with power of 2. we can safely remove the brackets to give 3 times 2, which gives us 2 to the power of 6, which gives us 64. In the second example, we have 2x squared in the brackets to the power of 3. Here, when we open the brackets, we have to multiply 3 into 2 and into x squared. This will give us 2 to the power of 3 times x to the power of 2 times 3. This gives us 8x to the power of 6. In the third example, we have 2 over x squared in brackets in the power of 3. Here we do the same principle as in the previous example. We put the power 3 into each term, which gives us 2 to the power of 3 divided by x2 times 3, which gives us 8 divided by x to the power of 6. Ensure that when you multiply n into the bracket, make sure you multiply into each value, such as 2 and x squared or 2 over x squared. In conclusion, we have learned on how to solve indices. We have covered index definition and the 6 index laws. If you enjoyed this video, please like and subscribe to my channel for more content. This is the Dynamic Maths channel signing off.